Okay. So we stopped at question
Sir, somebody
50.
is sleeping on call, sir.
It's okay, Mike. Don't care already. Feel. Who cares, right? Okay. The following equation is decay of uranium 235. So they said 23592 uranium becomes thorium, releasing one alpha particle. 42 helium is actually alpha particle. They said what is the value of the mass that is converted to energy? What they mean by this is sum of this uranium, when it becomes thorium and helium, it also loses some of its mass. So we're going to now calculate how much mass has it lost. So what we do is we need to make sure that this 235, the energy which is before is 235.0439, and then we're going to minus with thorium's unit of mass, which is 231.0363. So you minus with this, and then you minus with the value of the alpha particle, you'll find out how much value of mass is lost. So those mass which is lost eventually has become energy.
Sir, can I hear properly,
Was that
sir?
clear? The rest of you, can you guys hear me?
Yes, sir,
Yes,
can,
sir.
sir.
I think Ruben's connection. Yeah, sometimes it happens like that.
Connection kada.
It's been like that since CMO, mate. So what you guys do is takes uranium's mass minus with thorium's mass minus with alpha particles mass. How much do you guys get? So 235 minus 231. Eventually you'll get 4.0076. And then the 4.0076 minus with
26.
4.00262 U, and you'll end up with 0.005 U. So answer is B. So if the same question comes out in paper 2, they won't ask you like this. They say calculate the amount of mass lost. Question number 1. So when you calculate the amount of the mass lost, you'll find 0.005 U. And then the next subsequent question they'll ask you is what happened to this excess mass? So rather the mass is actually converted into energy. Okay, next one. So the answer is B, 50. Next question they say 49. Diagram 31 shows the radioactive decay series of nucleus W to nucleus Z. So that means W decays to X, then decays to Y, then decays to Z. So the one W to Z. So when it becomes, first of all, take a piece of paper and write. When it converts from W to X, how much has it lost? So if we look at the mass unit for W, the nuclear number is 212, and then the proton number is 88. Okay, you look at this dot here. So from here to here is 212, from here to here is 88, and then eventually becomes X, which is 20886. So 20886. So how much have it lost between 212 and, let me type this one down, huh? So it's like this. So 21288, which is W, then it becomes X, which is 20886 is X. So what is the byproduct? So from here 12 becoming 8 means 4 is lost. 88 becoming 6 means 2 is lost. So therefore there is one helium isotope, it's not atom, helium isotope, or you can call it alpha particle is lost during this process. Now do the next part. Repeat. So 20886 of X. Eventually this one becomes 20888. Let's say this one is y. When 208 becomes 208, there's no loss, so it's 0. 86 become 88. That means it added how much? So it's minus 2, correct?
Yeah.
So minus 2 only can be depicted by electron. So, as we all are or supposed to be aware, one alpha particle is the isotope of one helium isotope 42He. One beta particle is represented by 0, -1 electron. Gamma is represented by 0, 0. Okay, now. So now what is being released? How many beta? One beta is 0, -1. Here is 2, -2. That means 2 beta. So this one represents my alpha. Okay, next one. Repeat this thing again. 208 88 eventually becomes 204 86. So this tells us from 208 become 204. That means another 4 has been lost. 6 to become 86. So 2 has been lost. That's it. So this is the helium isotope. So this one represents 1 alpha as well. So total how many alpha and how many beta is lost? 2 alpha and 2 beta. All okay, you can understand? So the answer will be C. Can I people?
Yes, sir. Can, sir.
That's it, buddy. Next question.
Sir,
Yeah, ma.
I send you the answer ready. You see whether my working is correct or not. If like north, south and north, right? Then
Okay,
the
ma. Give me 5 minutes, ma. I'll check in a bit. Let me finish this one question, huh? Okay,
Okay,
next
sir.
one is 48. Diagram 30 shows the radioactive decay curve of a radioactive substance. So from the activity of 1/8 to 12, what is the half-life of the substance? Okay, when the first time, right, something becomes half-life, how much is it reduced to?
Half of it, right?
Correct. So the first time reduces, so it becomes half. So which one this one is 1/2, correct? How much is half of half? Is 1/4. That means half, first of all, first there's 1, and then 1 becomes half, and then half of half is 1/4, and half of 1/4 is 1/8. Okay, that means here you divide by, you times by half, times by half, times by half, times by half. That means how many times it has went through half-life? 1 time, 2 time, 3 times. So at the third time, right, it takes 12 seconds. So 12 divided by 3, that means every half-life is 4, 4 and 4 seconds. You understand?
Can, sir.
Come on. So answer is D, 4 minutes. Okay guys? Next one. Have you all tried this question already? This is pretty much straightforward, right? So they say which one is correct. This is 23892. 238 is the neutron, is the nucleon number, and 92 is the proton number. So automatically answer is C. This is like a bonus question. Okay, next one. We're going to look at this is transistors. Okay, this is one of the questions that will come out in your SPM, right? Don't share with your friends, but it's very, very important for you to understand how this transistor circuit works. Okay, transistor is also known as also known as also known as also known as also known as
சொல்லுங்க சார்
சார் நீங்களே அப்படி சொல்லிடுங்களேன்.
you must tell people it's known as automatic
Oh.
switch. Remember Saturday I told you
Oh.
guys transistor is
Okay,
also known
okay.
as switch automatic. That means it's an automatic switch based on circumstances. So now how does it work? So let me explain to you. Transistor. Let's see. Okay. Okay, watch this. So I believe all of you can watch this. Okay. Watch this, let me just okay. So now I'm gonna depict the current in red so you all know which way it's going. So current will move from the positive all the way to the negative. So current will move this way, current will move this way. Current wants to move down but cannot because this switch is off. Why is it off? I'll explain to you in a bit. So current cannot move this way because the circuit is broken because of the transistor. So current will move this way, current will move this way, current will move this way. Okay, now the reason why they have a thermistor, because thermistor decides how much of resistance in a circuit. Let's say, katakana, let's say, if the thermistor has 5 kilo ohm, assuming roughly here, so it passes through the 5 kilo ohm. Remember, this resistance has to be lower than this resistance. Okay, resistance here must be low, so that means this one should be around 6 to 7, let's say like 7 kilo ohms. But still current can go through here because this one is not open. It's the switch is open lah. Switch is open means current cannot flow. It's like wire been cut off. So now, where do you think the current will go? The current will go to the 10 kilo ohm or go to the 1 kilo ohm? Always remember, current is like river. River always flows in a place where there's lowest resistance. That means if you have, let's say you build a wall in one of these two rivers, so will you think the water want to go through the wall or will go through a hole? Where do you think? Come on, answer guys. Where do you think the water will go? Pass through a wall or go
1
through a hole?
kilo,
Sorry?
1 kilo.
Go
It will
through a
go through the
hole.
one. Yeah.
Yeah, because it's much more easy to go through a hole than go through a wall. So the current will go through one. The moment current goes through one and passes through the resistor, okay, this part, the bottom part is known as base. Once the base part got electricity, the switch is turned on. So once base got electricity, the switch is on. So now what will happen is, now current can also flow through this way. It will flow through this way, can flow through this way, flow through this way, flow through here and go through here. As long as there's current going through this way, there will always be current going through this way. Make sense or not? Do you all understand? Do you guys understand or not? I'm assuming you guys understand, because when this comes out in SPM, and if you don't understand, then you're in big trouble. And remember, guys, those that question that I already go through, right? I won't go through in class anymore. Huh? Once we sit down and we finish this part, if you guys are not here, I can't help it. So if you don't understand, you better tell me now, because there won't be any more repetition for this transistor part.
Explain one more time, sir.
Okay, explaining one more time. Just remember, if you want current to flow through the bulb, right? First, you must make sure current flows through the base. So this part is known as base. This part is known as collector. This part is known as emitter. Okay, the terminology is not so important, but I want you to understand. Only if there is current in the base, and only then the switch will allow current to flow through the bulb. Okay, my next question now. Let's say.
So were you explaining just now?
Yeah, I was explaining.
Okay.
Okay, now next question. So let's say we're gonna change this a bit. I'm not gonna use the okay, we're not gonna use the 1 kilo ohm. The 1 kilo ohm we cancel. So here's 10 kilo ohm. Here 5 kilo ohm. And let's say here is 30 kilo ohm. Will the current flow or not? Will the bulb switch on? Name Ruben?
So what's the bulb for resistor?
Now we forget about
Bulb
bulb resistance. Let's say it's low lah. Let's say we say it's 7 kilo ohm, like this now.
Okay.
Will the current flow or not?
No, sir.
Why?
Because it's too big, sir, the resistor.
Which one?
The 30.
Okay, fine. So you're saying that is big. So let's change this to 11. Will there be any flow? Will the light bulb light up?
No, sir.
Why?
Because the bulb is 7, the thermistor is 7, 11, sir. It's too big, so.
So what will happen to the current? Which way the current will flow? Now the current will actually insert between 10 and 11, since 11 is too big compared to 10, so current will flow downwards. So when current flows through downwards, right, is there any current going to the base or not?
No,
sir.
therefore the light won't light up.
Yeah. So therefore, the light bulb won't work because the base got no current. So the switch is still switched off.
So, sir, the kilo ohm must be between 5 to 10.
The
In
kilo ohm
order
can be
to-
anything as long as this part has to be lower.
Lower than?
Lower than this guy, the 10.
Okay, then only the current will pass through the base.
Right.
Sir, if let us like 11 change to 6 and this 10 to change to 5,
Same thing.
then what happens, sir?
Same thing, man. Won't work, lah.
The bulb
must be
won't
4.
light up, sir.
As long as the one at the bottom 10 must be lower than the 1 kilo ohm.
Sir, let's say like what Ruben said, the down one is 5 kilo ohm.
Uh-huh.
So the top one now must be 4 in order to
correct.
light the bulb to light up.
Correct.
Okay.
Then one student asked me once. Sir, what will happen if I remove the wire here, sir? Okay. The wire here is removed. Will the light bulb light up or not?
No.
Pardon? Will the light bulb light up?
Yeah.
Yeah, the light bulb will light up because current taboli, even though here is 10, the current cannot flow downwards because there's no circuit to flow. So current got no choice but have to go through the 11. And then you'll activate the
Okay.
base. So once base already been activated, the light bulb will light up. So if this is the case, why do we then have to have the wire down here? What is the function of this wire? Okay, if we started the wire di bawah, we don't have the wire at the bottom, right? There's no more automatic switch. Current has to go through here. This is like a normal circuit already. So there's no point of us calling this as automatic switch. Okay, I'll show you another example. I'm going to stop recording and then I'm going to show you another example.